Hi, I hope you're doing great. Today we will discuss a new topic that's called derivatives, specifically an introduction to derivatives. So you're gonna learn what is a derivative and how is it useful or where does it come from. So let's start. First of all, why do we use derivatives? Derivatives are used to find the slope of the tangent line at a point on a graph. So remember when I taught you before about slope? When you have a line, you know that each point on your line has the same slope. So that's why you say that the line has a slope of, in this case, for example, for this line, slope of 1. So as I said before, each point on that line has a slope of 1. But what about a parabola, for instance? This point, for example, point 1 has one slope, but the tangent line to point 2 here has another slope. So the derivative helps you find each slope of the tangent line of each point on that graph. So now let's check out something. Where does the derivative come from? Remember how I taught you in the last video about slopes that in order to find the slope of a line, you require this formula right here? Well, we will use it just now. Remember that this formula is also written as y2 minus y1 over x2 minus x1. So let's write this into a limit, with the limit of y2 minus y1 over the change of x, as change of x approaches 0. I will show you later why I wanted to approach 0. Now let's do some substitutions, or simply let's name our variables differently to make it easier. So instead of change of x, we will write h, just to make things easier, just to drop off this delta that could confuse us later, okay? Now, our y1 will be f of x, and our y2 will be f of x plus h. You must be asking, why did I write an h here? I did it to represent that there are 2 points and that there is a difference between them. Now, how big is that difference? That's what will come next, okay? So, simply what we do now is write our limit using the same limit here, but using this new names for our variables. And that will be the limit of f of x plus h minus f of x over h as h approaches 0. Now, why did I write as h approaches 0? Remember that f of x plus h minus f of x are 2 points, say these 2 points. And the derivative is trying to find the slope of just 1 point. So we're trying to get the difference h between these 2 points to be as small as possible, as minimum. So until they can clash and become just 1 point, which we can find the slope or the tangent line slope of that. Now let's practice with an example. So now let's write the formula or the limit that we just created, which was a limit of f x plus h minus f of x over h as h approaches 0. But right now, I think it's easier to drop off this limit just to make things easier, and once we have finished doing this, then we can add the limit. So let's erase this first, okay? And then simply substitute or add your function. So that would be 16. Instead of x here, I'm going to write x plus h squared minus 16x squared over h. Now let's solve this x plus h squared, and that will be 16 times x squared plus 2xh plus h squared minus 16x squared over h. And now if we continue, this will be 16x squared plus 32xh plus 16h squared minus 16x squared. Notice here I simply multiplied this 16 by everything that's inside the parentheses, and then simply copy this, and that will be over the same denominator, which is h, okay? And simply here what we must do is cancel out this 16 with this 16 since they are subtracting, and simply copy out this, which is 32xh plus 16h squared over h. Notice how every every monomial in my numerator has an h. So I can cancel out those h's in here. Here I'll reduce this h exponent to 1, and then I'll be left off with something like that, like this. And here I'm gonna add my limit as x approaches, as h approaches 0, of 32x plus 16h. Now I'm gonna add to this. Instead of writing an h, I'll write a 0. So it'll be 32x plus 16 times 0. This will cancel out. And then we will be left off with the answer, which is 32x. And then 32x is the derivative of this function.